You're listening to the Banana Data Podcast, a podcast hosted by Data IQ. I'm Trevani.
And I'm Will.
And we'll be taking you behind the curtain of the AI hype, exploring what it is
and what it isn't
capable of. This episode, we're looking at data science after deployment, sitting down with Dan Shiebler, senior machine learning engineer at Twitter, to explore what it means to maintain models in production and how to tackle problems like technical debt and complexity.
I'm excited for this conversation because I think it's definitely underrated to think about productionalization of data science. Before we even begin, like when I mentioned technical debt, what do you think of when you think of technical debt?
I mean, I don't know. I think of like owing money to a bank.
Yeah, I mean, I think that's where the term debt comes from, right? But so in general, just to be clear for our listeners, I think the definition of technical debt is just this concept of making somehow long-term poor technical decisions in search of a short win, right? So I'm sure you've done this before too. I've definitely done it. I'll speak for myself. I've definitely done it where I've written code and I've known in some way that this was inappropriate in the grand scheme, or it was suboptimal in the grand scheme, but it was just a quick fix. I mean, it was figurative duct tape. Yeah. But you could think about, duct tape. It's probably not the best way to stitch two things together, but it's a quick fix, gets it done in a pinch. And so in general, I think oftentimes this technical debt builds up in an organization where so often you're just flying by the seat of your pants, trying to ship models, maintain models, and suddenly, before you know it, you have all this stuff glued together. You're not really sure what model's doing what, who's owning what, where it's running.
Absolutely. I mean, I think I've experienced it in my own sort of work history and with clients where it's like, okay, here's what you need. We'll refactor it later. And you keep saying that. And then all of a sudden, this non-refactored code, which is not great, is literally in production, right? It's like what's driving your business value. And that can be really brittle.
It's a tricky challenge though, right? It's so easy to say, oh, we'll do it later. We'll put this formality in process later, right? Because when you're a small growing organization, you don't feel like you have time for this overly formal, overly bureaucratic system of code checks and code maintenance and code quality and oversight of productionalization of models. So again, when do you introduce those practices? I'm not really sure. But just another point that I think I heard this at another meetup talk. It was not necessarily even a Data IQ meetup talk. Some meetup talk, an individual was talking about productionalization of data science. And I think just to be clear, so often no one thinks about the repeated use of machine learning models, or at least academics don't, right? When you're learning about this in school, you're performing training on a model once to get a high score once. Think about Kaggle. But in general, at this meetup talk, the individual made a nice analogy between data pipelines and data productionalization and McDonald's French fries. And if you think about French fries, right, like you need to produce them, but then also you need to make sure that you have quality assurance over time, or just hopefully any food that's being produced by a large manufacturer. Not only are they making it, they're doing quality checks to make sure that this thing is staying of the quality they hope that it is. And so again, something that I think Twitter knows a lot about, and we need to be focusing more and more on in this community.
Yeah, absolutely. I think it's interesting because we talk about putting models into production, or we say like productionalize your data science. And I think people misunderstand that as like, oh, it just means using it on your real data, right? Like you're not using your play data anymore. You're not using your design instance. You're going into production. But it's more than just putting something out there, right? It is actually looking at it, maintaining it, checking it for things that you want to be doing. And I think, hopefully Dan will be able to tell us, what does that really mean in the larger scale of things to productionalize, right? Why should we even care about it beyond the idea of now it's happening on the real data?
And even how models interact with other models.
Oh, yeah.
So if I'm making a model, it's changing customer behavior. Nothing lives in isolation. So once it's put into production, it's going to change the data. It's going to change user actions. It's going to change other machine learning models. So it's a complex ecosystem, and I look forward to learning more.
So before we go to our guest interview, we're going to do the part of the podcast that we call In English, Please, where we explain complex data science topics in plain English. So Will, last week you mentioned reinforcement learning. So I'd love for you to explain reinforcement learning in English, please.
Reinforcement learning can also be known as online learning, and it's sometimes considered the third learning technique in machine learning. So in addition to unsupervised and supervised learning techniques, which I'm sure many of our listeners are more familiar with. Whereas in supervised learning, we have an associated label of truth for each observation. We don't have such a label in both unsupervised and in reinforcement learning scenarios. So crucially, reinforcement learning, it works in a context where actions do ultimately receive some feedback. And this feedback is sometimes referred to as a reward function, whereby useful actions, they get high rewards, unproductive actions get low rewards. So consider an example. Maybe you're trying to train some little robot mouse to complete a maze. And so if we thought about this like a supervised learning problem, well, first, we need to make a data set where every observation was a path in the maze. And then every path in the maze was either labeled with a success, aka the mouse escaped the maze, or a failure, aka the mouse did not escape the maze. And so this would take a lot of hard work to make some sort of data set like this, given that there's an infinite number of ways that this mouse can move through the maze. So instead, in a reinforcement learning setup, we can just code the mouse to move per some adaptive instructions. That's, where the complication of reinforcement learning algorithms come in. But then after each run, this robo-mouse will, using reinforcement learning methods, incorporate the feedback, aka it escaped or not, into its future behavior. So in this way, it's adapting so as to take actions that associate with higher rewards and adapting so as to minimize actions that do not. So in this way, good behavior is reinforced, hence the name. So reinforcement learning methods are commonly used in places like robotics, where feedback, aka the robot fell or not, is easily gained, but also used in other worlds like product recommendations. And faithful listeners may recall that in the past, we referenced Stitch Fix in Multi-Armed Bandits, which is an example of a reinforcement learning algorithm.
Thanks for explaining that in English. Today on the podcast, we have a special guest with us, Dan Shiebler, who is a senior machine learning engineer at Twitter. And he's here to talk to us today about productionalizing data science and lots of other cool stuff. But welcome to the show. Tell us a little bit about yourself, Dan.
So I'm Dan, work as a senior machine learning engineer at Twitter. In my job, I build machine learning models and also develop systems and tools for training and deploying models at scale throughout Twitter. Before I was at Twitter, I was at TrueMotion, a startup in Boston, where I worked as a data scientist, much more of a startup environment to initially develop my machine learning skills.
You seems like you do a lot.
I suppose.
I feel like for a very mature organization or a very mature tech organization like Twitter, typically I would imagine that someone was purely focused on data science or ML or model development, let's use a simple term, but you're doing like that in model deployment systems. How do you balance your time between the two? And also, how do you wish you balance your time, and how does Twitter wish you balance your time?
Sure.
What's the trade-off in terms of the importance of model development versus model management?
Yeah, that's a really great question. So at Twitter, it's split across a lot of different organizations and teams in the way that machine learning tasks fall out. So Cortex is the central machine learning team at Twitter. We're responsible for building the core machine learning tooling and systems upon which models are trained. But there's a great deal of involvement that Cortex has in the individual models that product teams own. My team is the MLX, Machine Learning Extended team within Cortex. We develop approximate nearest neighbor models on top of embeddings for various kinds of content in order to power recommendation systems throughout Twitter. And so in my job, I have things from the range of developing the systems to train and deploy these models, as well as partnering with individual product teams to develop individual models for a particular product surface.
Right. I think probably when we think of what Twitter is doing with ML, we're thinking of recommendations of like, hey, you should follow this person because you follow this other one, or here's an ad, or here's a promoted tweet. But I'm sure that there are lots of other ML use cases between cleaning up bots that are not doing the right thing, or pictures that are inappropriate, all of that. I'm guessing there's lots of ML use cases out there.
Yeah, I mean, the goal is to create a good user experience, and that has a lot of different pieces to it. It's very important to be able to serve content people want to see and people are going to be interested in, but it's also important to make sure that conversations are healthy on the platform and that there's not things that break our terms of service being surfaced. There's hundreds of millions of tweets that get surfaced on Twitter every day, and it's not possible to check every single one of them manually to make sure that they're compliant with terms of service. And so automated techniques like machine learning models really help with that.
Yeah, I think it's interesting how you say that the purpose is to, elevate the user experience. I think so much we talk on this podcast about machine learning to like predict some outcome or predict how our user is going to buy more or whatever it might be, very like business oriented. And user experience is a part of a business, right? It is a part of a model to provide a good service. I'd love for us to take a step back and talk about what does it mean to productionalize data science. Last week on the podcast, we actually talked about data pipelines, right? And machine learning pipelines. Given that, someone at Twitter or anywhere has created this end-to-end sort of ML algorithm or whatever it might be, bringing in the data, cleaning it, doing the analysis, and now they want to, quote, put it in production or deploy it to a production system. What does that really mean? Why even care about productionalized data science? And, what are people missing when they talk about that?
So there's a lot of pieces to production data science that range from the deployment process and maintenance process to the actual underlying issue of, does your model help the core company metrics? Data science is a very broad term. Production machine learning, even in just specific, is not just the process of bringing a trained model that you built into production. It's the entire life cycle of thinking about starting with the question, do I actually need a machine learning model to solve this? And whenever you can say no, you probably should, because a machine learning model is an enormous engineering drain and burden. And if it's possible to do things without one, that's usually the best option. And so when you've decided that you absolutely, no matter what, have to develop a machine learning model for this particular product use case, trying to develop it in a way that makes these really aggravating long-term effects as minimally draining as possible is almost always the best strategy. A 10% increase in model performance may cost a 300 to 400% increase in engineering resources, and that's rarely a trade-off that's worth it.
So what you're saying is that the challenges of productionalizing data science don't come necessarily from the tooling of like, how am I going to get this model into production, but more so, how am I going to keep this model useful long-term without a huge burden to my team or to my resources?
That is fair. And there's also the question of how much does bringing this model into production affect the entire ecosystem within which this model is going to be operating. When you have a data pipeline that feeds in data to train a model and then some sort of set of systems to hydrate features for a model in production so that somehow whatever you were training your model on is in concordance with what you were predicting on in production, this alone is already a really complex process because features come from upstream sources, especially a really complex feature like an embedding. You end up with extraordinarily complex chains of dependencies as models get more complex and data pipelines get more complex, where small changes by some upstream team can significantly damage downstream models if they're not extremely careful about deployment process. And even more critically, as a model is built and hosted into production, it could be that the product surface, for one reason or another, changes. Maybe somebody deploys another model somewhere else in the pipeline that makes the degree to which your model drives user experience no longer large enough to justify its maintenance cost. And it's extremely important to always be raising the question of whether or not a model is still useful and still driving value. To give a concrete example, perhaps I'm developing a model that allows me to serve a new kind of candidate on the timeline, taking advantage of some new kind of information about a user in order to surface tweets that we think they may like. But up until this point, all of the models that we've developed have not been using this kind of feature. Once I start serving these sorts of tweets, it could be that these new sorts of tweets that are going to be appearing in people's timelines are things that will drive the core metrics I'm looking at. Maybe I'm looking to increase engagement or to increase daily active users. And I could see these things starting to go up. But at the same time, I've changed the underlying distribution by which tweets are served. And in doing so, I may have affected other people's models, whose models were making assumptions about that distribution that I've now broken. So I may hurt other people's performances by adding my model and changing this careful balance and delicate relationship between this ecosystem of models and software systems. There's enormous number of effects that any kind of hard to understand model may have. And so erring towards simplicity and really understanding your landscape as you develop machine learning models and put them into production with an eye towards actual business metric wins as opposed to just what seems cool and what drives whatever you're tracking at the moment is the real way to make an impact in a production environment.
So I hear you talking about not just model deployment, but monitoring the models for impact on the business. And to me, the term of causality seems relevant here, right? Like not just saying that we have these models in production and this is the status quo of Twitter's core metrics, but rather saying this model is contributing to those core metrics in this way. So first of all, how do you guys try to go about that attribution of model to metric? And second of all, whose responsibility is it? Is it the responsibility of the ML team who created that model, or do you have a whole separate unit?
Yeah, I mean, we have a pretty well-developed A/B testing framework that we utilize to handle different kinds of model attributions. There's many people and many teams whose full-time job it is to think about all the ways that we can assess these sorts of things, because you could use similar techniques. When it comes to attribution, you could use similar techniques that you would utilize for various kinds of A/B testing approaches as you use for machine learning models. So the general solutions work quite well there. There is a fleet of people who are in charge of developing and maintaining A/B testing infrastructure, but in terms of assessing whether or not a model is making an impact on product metrics and making sure that it is continuing to make an impact on product metrics and making adjustments to the model and to the product when necessary in order to maintain and increase that impact, a lot of that falls on the product team or whichever modeling teams are partnering with them, which some cases is my team, some cases in other teams.
Interesting. So it's a combination of people who are maybe embedded in the product or embedded in the business with the folks who are building out these models themselves, right? It can't necessarily be these silos of ML team made something, gave it to product put it into production or deployed it, and now business operations or business users are like, great, thanks, right? This seems like a very sort of complex ecosystem. There's feedback, there's information that has to travel back and forth.
In my experience, it almost never works for a team to separate the people who are building a model from the product team that's deploying it, except in the case where the problem is extremely well understood. But the closer you are to something new, especially to something that's changing fast, the closer coordination and communication you need between the people who are building a model and the people who are going to be maintaining and deploying that model. In many cases, you need them either to be the same people or to be people who are working very closely together.
So what you're saying is that the engineers at Twitter are not locked in the basement.
Yeah.
That's good. That's good to know.
Not.
So I have in my notes here that previously you designed smartphone sensor algorithms for car insurance at TrueMotion. So I'd like to hear a little bit about, more broadly, how you think different organizations and their productionalization of data science differ. Are the things that are threads that run constant regardless of organization, or is every company and every company's ML team, a snowflake and unique?
So I'd say that one of the largest differences between the way things worked at TrueMotion and the sort of things that were successful at TrueMotion and the sort of things that was successful at Twitter is a dichotomy that is very easy to find elsewhere. And that is that TrueMotion was a small startup that had been founded relatively recently, whereas Twitter is not a massive company, but many, many times larger, or almost 100 times larger than TrueMotion was. So at TrueMotion, it was the case that if I built a model to detect hard braking, so many of the models we were detecting were being utilized for insurance scores by detecting various kinds of dangerous driving behaviors from motion sensors and GPS sensors. So if I built an algorithm to detect hard braking behavior, I would probably be the first algorithm that detected hard braking behavior. And so even a simple approach that did a reasonable job at detecting this may significantly improve the company's position. And at the same time, we did not have the kind of rigorous A/B testing framework that Twitter did. That actually changed over the course of my time at TrueMotion. Just as I was leaving, we were building out the A/B testing framework. But attribution was not a solved problem by any means. To an extent, that was a attribution wasn't all that necessary because there weren't that many things going on. Unlike Twitter, where you have hundreds of things going into production every day, that there might be 2 changes a day or 1 change a day. There wasn't 10 other engineers working on hard braking like there are hundreds of other engineers working on timeline ranking at Twitter. Many of the challenges that Twitter spends huge amounts of engineering resources to solve, TrueMotion just didn't face. And many of the ways that the kinds of problems that Twitter was solving, TrueMotion was simply too early stage to face. Many of the most sophisticated models at Twitter are taking advantage of a combination of fruit that's not quite low-hanging, but still very bountiful, and a complex relationship between different components. At TrueMotion, if you were doing anything other than picking low-hanging fruits, you were probably wasting your time because there was so much that hadn't been built yet.
So would you say, correct me if I'm wrong, but at TrueMotion, it was just a matter of collecting low-hanging fruits and quickly getting easy wins. At Twitter, I take it that's not the case because so much of that low-hanging fruit has been collected. So therefore, would you say the biggest obstacles that are facing you in your quest to help improve the Twitter user experience, let's say, are they this concept of operational issues in terms of productionalizing ML and inter-team collaboration? Or is it just, if we really had a better text classifier, that would solve all of our problems? Is it more on the ML side or on the kind of the DevOps, data ops, productionalization side?
I mean, I would definitely say there's far more time spent on the productionization strategies and various kinds of challenges with maintaining machine learning models and fitting machine learning models into the ecosystem. I would say that there are a few cases where really significant modeling improvements can have a humongous impact. And when we can come across these kinds of issues and dedicate the resources to building these sorts of things out, it ends up being a very worthwhile endeavor. You need to balance exploration and exploitation, and you need to realize the difference between an investment that has the potential for a humongous win, but will take a long time because it's going to require lots of infrastructure changes, versus things that simply aren't worth it in the short term. Any kind of change is going to introduce huge amounts of technical debt and huge amounts of maintenance cost. And determining the trade-off of, do I really expect this to be 10 times better than the thing that's going to cause 10 times less maintenance cost, or do I only think it's going to be 50% better? And making trade-offs with these kinds of things in mind is really important. And there are definitely cases where we identify things that say we really think we can get a 10x improvement here and put the time and effort into deploying those. But it's careful selection of what exactly are those places where we have that leverage potential.
Sounds like those are management skills that are a little bit different than what they've been teaching in the Harvard Business School for most of the time, I would imagine. But that sounds like an interesting new class of manager who's thinking not just about allocation of human resources, but allocation of human resources with regards to ML or data investment or software investment.
Absolutely. I really agree. I think that there's interplay between technical leadership and management that's necessary for that kind of decision making.
Well, when we think about the future of data science, right, and the new cohort of data scientists coming into the field, right, whether it's from a boot camp or PhD transitions or whatever it might be, why should those folks even care or know about productionalized data science, right? So much of what people are learning is, here's how do you data cleanse, here's how you build the model, boom, you're done. Go, here's your little degree and have fun. Does the average data scientist need to care? If they do, how can they learn about this before joining the workforce? Or maybe do they learn this on the job? What do you suggest?
And so I would say that it is important to know about productionized data science because you can really define the productionization process as the process of transforming a model into impact. And impact is really what you're hired for. If you are unable to create impact, it is unlikely that your company will be happy with you as an employee, or that you will have a great amount of success as an employee. That is one of the largest areas of important skills for somebody to develop over time. And there's many different ways to create impact. People can create impact as being dedicated researchers. Many people who come out of PhD programs join tech companies in more research roles where they don't think that much about productionized data science because their company is sort of directing their skills in a different direction. But people who are joining with job titles more like ML engineer or data science, where they are being directed towards production problems and expected to work within a production ecosystem, it is largely, I would say, almost all of what is expected in the long term is driving impact one way or another. And understanding the production process is absolutely critical for that.
Yeah. I mean, it sounds like no matter how fine-tuned your one specific algorithm is or your model is, if it doesn't actually give anything back to the business, it's not. Like you can have an AUC of 9.99 and say this is the best model on earth, but it actually isn't giving you anything, right? You're not actually able to do anything with that information.
If your model is excellent and incredibly great offline, but is driving no use to the business, it's almost certainly a net negative because you've spent a bunch of time and the company had to pay you to do that. And you probably needed to talk to other people and took their time to put it into production. One of my own team's key objectives this past quarter was shutting down some models that have outlived their usefulness. When you identify a model that's outlived its usefulness and shut it down, you've served the company. A model that's not useful but is in production and is dragging on engineering resources and compute resources is a net negative.
So I'm hearing kind of in like summation, right? Productionalized data science is so much, right? From the beginning where you're providing access to sort of regularized features or data sets to maintaining and putting into play models that have impact, but then also measuring that impact and where you're not seeing it, being willing to sort of pull the plug. It really is like an ecosystem of governance almost than like what we might think of production.
I think describing it as an ecosystem is a good way to think about it. Definitely. There's a life cycle that includes both birth and death and a great deal of interaction with many other things.
Well, we're almost out of time with Dan here, but before we head out, I have to ask this burning question. Are you allowed to browse Twitter at work?
Everybody has to use the product.
No, so you have to be on Twitter.
Yeah, you don't. Nobody's forcing you, but how could you really understand your users or know what to build or get a feel for what the user experience is if you don't browse the product? How do you get ideas if you don't open your feed and be like, why am I being shown this? This is a terrible recommendation. I need to figure out why I'm being shown this.
And what do you like to see in your Twitter feed?
I'm pretty nerdy. I follow basically exclusively machine learning people and category theory people.
And who's your favorite Twitter follow?
Oh, man. That's a great question. You know what? I'm not entirely sure. I have really enjoyed watching the Jan LeCun versus Gary Marcus debate recently. Those two are not the only people involved, but it's part of a larger debate on the relative benefits and capabilities of systems based entirely on pattern recognition versus ones that are trying to incorporate a combination of logical reasoning and symbol-based reasoning, and the degree to which those kinds of strategies may be able to do better in core AI applications than things that are more learned end-to-end.
Nice. That is deeply nerdy. I appreciate it.
Well, Dan, it's been a real pleasure. We've enjoyed our time, and I know our listeners will benefit very much from your knowledge as well. So thanks so much for your time tonight.
Thank you.
Thanks for being here. So now it's time for Facts That Are Bananas before we sign off. And keeping in line with the spirit of today's episode, today's fact is the most used emoji in tweets is the face with tears of joy emoji. And that's been used more than 2 billion times on Twitter. If you're interested in seeing what other emojis are used on Twitter and how much, you can look at them at emojitracker.com.
Do you know what my favorite emoji is, Jabrini?
The poop.
No, definitely the shrug. By far the shrug. That's all we've got for today in the world of Banana Data. We'll be back with another podcast in 2 weeks, but in the meantime, subscribe to the Banana Data newsletter to read these articles and more like them. We've got links for all the articles we discussed today in the show notes. All right, well, it's been a pleasure, Jabrini.
It's been great, Will. See you next time.